Alright, so in chapter 3.6, solving systems of equations in three variables. Now that we understood that we can have a linear system, or linear equation rather, written in three variables, we need to know that we can also have a linear system that has three equations in three variables. And in sections 3.1 and 3.2, we learned how to solve a linear system in two variables. So let's go ahead and use those same principles and apply them to a linear equation, a system of equation in three variables. So the way that we can do it, we can take the ordered triple. If we just wanted to see if this solution worked, we can take a solution set and substitute it into the equation to see if it's true and satisfies all three equations. So we could just do that real fast, and we see that our ordered triple is 2, negative 1, 1. And in order for this to be a solution to the linear system, meaning that this point will intersect the three lines or the three planes there, it has to be true. So let's see. If we substitute x2 into the first equation, plus 2 times negative 1 in the second variable, plus, I'll just put plus negative 3 times 1 equals to negative 3. Is that true? Well, we have 2 plus negative 2, and then we have here minus 3. And does that equal to negative 3? Well, these 2's will cancel. 2 plus negative 2 is 0. And 0 subtract 3 is negative 3. And that first equation is true. And because that works out, we know that the first equation satisfies. Then we could try the second one. I'll do that over here on the left. If we do the second equation, substituting 2 in there, positive 2. Subtract 5 times negative 1. And then we have plus 4 times z. And since z is 1, we need to see if that will equal to 13. 2 times 2 is 4. The two negatives together becomes a plus. That's a 5 plus 4. And if we add those up, do we get 13? Well, 4 plus 5 is 9, and 9 plus 4 is 13. And because these are both true, we know that that one's equal. The last thing we will need to do is see if the third equation is true. And if it is, we know that the ordered triple is a solution to the linear system. Alright, so if we substitute in there for x, we have 2 plus 4 times y, that's negative 1. Subtract z, would just be 1. Does that equal to 5? Well, 5 times 2 is 10, plus that 4 times negative 1 will give us negative 4. Subtract 1, does it equal 5? Well, 10 subtract 4 is positive 6, sorry. And positive 6 subtract 1 is indeed 5. And because when we substitute the order triple into each of the equations in that linear system, that they are all satisfied, it makes 2, negative 1, 1, the order triple, a solution to that linear system. Now, if we wanted to do the opposite, we receive a linear system and we want to solve it to see what x and y and z are all equal to, we can do something similar to what we've done in chapters 3.1 and 3.2. And what we're going to do is we're going to use the linear combination method, and within there we're also going to use the concepts of substitution to do so. Now this is found in the book on page 178 in Algebra 2 book. And the three steps we see there is simply use the linear combination method, also known as elimination, to rewrite the linear system in three variables as a linear system in two variables. Now what does that mean? Well, it means that we're going to solve the linear system for both of the second variables. So if we had x, y, and z, we're going to eliminate the z variable and then try to use the x, y to do a regular linear system as we did in 3.1 and 3.2. Once we're finished, we're going to use the substitution method and then find the values that we found in step 2 back into the original equations to find the remaining variable. Now, there are three things that we want to note. If we obtain a false equation, such as 0 equals 1, 5 equals 2, anything where it's false, then the whole thing has no solution. If we find an identity, such as 0 equals 0, 5 equals 5, 7 equals 7, then it will have infinitely many solutions, just like we saw with parallel lines, etc. And obviously, if you get a unique solution, you found the actual ordered triple. Alright, so let's go ahead and put this into action. What we want to do is eliminate one of the variables, and we can choose which one to eliminate by looking at the variables that we have. Just like we did in chapters 3.1 and 3.2, we eliminated the easiest variable. And so as you can see, none of the coefficients are the same, so we can't eliminate right off the bat. But what we can do is modify it. And if you look at the middle term, that's the easiest one to modify. And so that's what we're going to start with. And I'm going to start off underneath, and I'm going to choose the first equation and the second equation. And the second equation, I'm going to times that by positive 2, because that will make these two coefficients the same and opposite. And so I can eliminate the y's and then work with my z's. All right, so underneath there, let's start that. We're going to have 3x plus 2y plus 4z equals to 11. When I multiply the second equation, I'm going to end up with positive 4x, subtract 2y, plus 6z equals to 8. And because those are opposite, we can simply add, and that means we're adding everywhere. When we add, those two will cancel, and so we're going to end up with 3 plus 4x is 7x, 4z plus 6z will be 10z, and 11 plus 8 is going to give us 19. All right, we can do the same thing with the other two, the first and the third one. If we do that with the first and third one, what will happen is we will eliminate the y again. Now, when you do that, when you pick the next set, you want to make sure you don't eliminate another variable, because then your second one won't match up. If you start off eliminating the y, you want to continue eliminating the y. All right, so I'm going to change the color so it stands out easier. So this time we're going to pick the second equation and the third equation. So I'm going to have here 5x subtract 3y plus 5z equals to negative 1. Now, for this one, I'm just going to cross this out so you can still see it. I'm going to times this one by a negative 3. That negative 3 will turn that middle y to a positive 3y, and it can cancel now with that one. And so then we're left with just the z's and the x's. All right, so let's go ahead and do that. I've written out the third equation. Now this new modified second equation is going to be negative 3 times 2 is negative 6x. The negative 3 times the negative y is going to give us positive 3y. And then the negative 3 times the positive 3z is going to give us negative 9z. And negative 3 times 4, negative 12. All right, so now we can just add. We're adding everywhere. That's how this cancels. So since I know I'm adding to cancel that, I can add each of the other variables and coefficients. So 5x subtract 6x is going to give us negative x. And then the 5z plus a negative 9z will give us negative 4z, or just subtract 4z. And remember, we're adding on that last column where the answers are. So negative 1 plus negative 12 is going to give us negative 13. So now we have two new equations. We have new equation 1 and then new equation 2. And now we're going to use our understanding from 3.1 to eliminate these two new equations. All right, so we're going to rewrite them up on the side. And so we're going to have 7x plus 10 z equals to 19, and then negative x subtract 4z equals to negative 13. All right, so same thing, we're going to have to eliminate these. To do so, you see that the variables are not the same. So that means I want to modify one of them. It would be easier here to just multiply this by 7. And by 7, I mean the second row. If I multiply this second row by 7, positive 7, I can eliminate the x's in the next line. So let's go ahead and do that. I'm going to use a maroonish color there. So we're going to have, just rewriting now, 7x plus 10z equals to 19. In the second row now, multiplying that 7, I'm going to have negative 7x, subtract 28z, and then 7 times 13, that's going to give us 7 times 10 is 70, and then 7 times 3 is 21. So we add that together, that's going to be 91, so negative 91. All right, so now we can eliminate. To eliminate those x's, we would have to add. So we're adding everywhere. So those will cancel. 10z plus negative 28z, it's going to give us negative 18z. And then 19 plus negative 1, wow, that's going to give us negative 72. So negative 72. So now to find that variable z, I just simply divide everything by negative 18. And that's going to give us our answer. We know that 9 can go into 72. And 9 goes into 72 8 times. Since 18 is double that, it's going to be half of that. answer. So that's going to be z is going to be equal to positive 4. All right, so z equals to positive 4. Now we could take that z and we can substitute the z back into one of the new equations because they're just x and z. So I could choose either new equation 1 or new equation 2. And so if I now substitute my z equals to 4, I like positive values, but small answers can sometimes be easier. So let's substitute into this one. Negative x minus 4 times 4 equals to negative 13. Those two 4's together is going to give us 16. So we have negative x minus 16 is equal to negative 13. We can add 16 on both sides, and negative 13, my pen just stopped, and positive 16 and negative 13 is going to give us a positive 3. And then we can multiply by negative 1 on both sides or divide by negative 1 on both sides. So we end up with x equals to negative 3. So now we have two of our variables, x and z. And so now we could take those x and z's and substitute it into one of the three original equations. And normally you want to choose the easiest one because that middle equation, doesn't have a coefficient. That could be the easiest one, and plus the coefficients are smaller. So we could take our x and our z and substitute it into 2x subtract y plus 3z equals to 4. All right, so if we do that, we have x is negative 3. So that's 2 times negative 3 subtract y, which we don't know yet, plus 3 times z, which is 4. Okay, so if we simplify all that, we have negative 6 subtract y plus 12 equals to 4. That negative 6 and 12 together is going to give us positive 6. And then if we bring that 6 over to the other side, that's going to be 4 subtract 6. So we have negative y equals to negative 2. And then we can multiply or divide by negative 1. That's going to give us positive 2. And so now we have our ordered triple. Our ordered triple, or the solution to the equation, is going to be x equals to negative 3, y would be equal to positive 2, and z would be equal to positive 4. And if we wrote it in ordered triple form, negative 3, 2, 4. And we could actually go and graph these and show what it will actually look like. But that's our answer, and that's how we find a system with a unique solution. The steps to this can also be found in the book as well.